do some recording so that you can refer in the future. All right. Okay, in the previous lesson, I already explained to you what is the how to determine the scale of the scale of the scale of the thermometer. So remember how to find the temperatures, right? All right. Now today we go further a bit to see how to make the how to increase the sensitivity of a thermometer. All right. Okay, can you tell me what is mean by sensitivity? What do you understand about sensitivity? Yes, Nelly? What do you understand about sensitivity? Nelly, I can't hear you. I think you hasn't opened your mic yet. I can't hear you. I can't hear you. You check your mic. Already unmute. Unmute me, but I can't hear you. Testing, testing. Yeah, let me test my speaker. I try to rejoin. Try to rejoin. I can't hear you. All right. All right. So, okay. So in the previous lesson, I already explained to you what is thermal equilibrium conditions, and then how to determine the scale of the thermometer. Scale of thermometer. Now, today we go further a bit. We see how to increase the sensitivity of the thermometer. So, before that, we had to understand what is meant by sensitivity. Sensitivity means how good an instrument respond to the changes. Now, for example, let's say you use a infrared thermometer to scan your temperature. So you can get your body temperature within a few seconds. So that means it is very sensitive. You can get the result very fast. That is called sensitive. If you had to wait very long time to get a result, that means it is not sensitive enough. All right. So there are a few ways to increase the sensitivity of thermometer. There are a few ways. Now, first way, we need to have a finer bowl. So what is bowl? Bowl is this part of the thermometer, this part. Or we can say the capillary tube. Yeah, so this is called capillary tube. This one. This tube must be fine enough. Okay, so when you fine enough, a little bit rise in the rise in the mercury, you can see very big difference in the increase of the height. You can see a very big difference. So this is called capillary, finer capillary. All right, I try to compare these two, A and B. Try to compare A and B when the temperature rise for a bigger or thicker tube, it just rise a bit only, you see. So finer tube, it can rise a lot. So when you rise a lot, you can see a big changes. when you can see a big changes, you can determine the change easily. Okay, so this is called final bulk. Okay, so this part, okay. All right, okay, now second one, a smaller bulb. So this is called bulb. It look like the bulb of the lampu, right? Look like a bulb. So smaller bulb is more sensitive because when smaller bulb, the heat up lesser mercury, or it can heat up the mercury faster. So the change, it responds faster. So if the bulb is bigger, it take longer time to heat up the mercury. So it take longer time to rise. So this is the second way to increase the sensitivity. And the third way is thinner glass wall. I try to compare. So this is a thinner glass wall. So before the heat transfer to the mercury, it need to pass through the glass wall first, right? Before it can reach the mercury, right? So if the glass wall is too thick, it takes some time. It takes some time to heat up the glass wall first before the heat can reach the mercury. So that's why thicker take longer time. Thinner wall is more sensitive to respond. All right, is that clear? So this is a way we can increase the sensitivity of the thermometer. All right. Okay, so far this part okay? And okay, if no problem, we move on to the second part, specific heat capacity. All right, second. A few minutes now. Yeah. Okay, so what is meant by specific capacity? So you have to focus on the words capacity. Capacity. Capacity means the storage, right? The storage of something, capacity. So for example, when you buy a power bank, you have to know the capacity of the power bank, right? So let's say you want to buy a container or anything to fill up something, you need to know the capacity. How big the container can store any foods. So now all the material also has its capacity to fill up heat, have a capacity to store heat. Different materials or different substances, they have different capacity to store heat. All right, okay, let's see two different materials. So on my left hand side, there is a water, 1 kg of water. Okay, on the right hand side is 1 kg of iron. So these two materials have different specific heat capacity. Okay, now, okay, so for iron, the specific heat capacity is 450 joule per kg per degree Celsius. So that means 1 kg of iron absorb 450 joule of heat energy to rise 1 degree Celsius. So this is a definition of specific heat capacity. Okay. Now specific means specific to 1 kg. Specific means specific to 1 kg. Okay, all right. Now what about water? Now water have a specific capacity 4,200 joule per kg per degree Celsius. So that means 1 kg for every 1 kg of water, it absorbs 4,200 joule of heat energy to rise 1 degree Celsius. So the water has a bigger capacity. All right. Now, maybe you can try to think in this way. Okay, let's see. Okay, try to assume that I have two containers. Two containers on the left-hand side is A. Right-hand side is B. There are two containers. So I pour the water into these two containers at the same speed. Okay, at the same speed. Now you see. So which one will rise up faster? Container A or container B? So which one? The water will rise up. The water level will rise up faster. A or B? See again. I pour the water into the container, two different type of container, A and B. So which container the water level will rise up faster? A or B? So the bigger one take a longer time to rise up, right? You see? You need to fill up this water, the water here, right? Before you can rise up. But this one you fill up a bit only, right? It can rise up, right? But anyway, which one the capacity is bigger? A or B? Which one has a bigger capacity? A or B? Which container give a bigger capacity? Container A or container B? Capacity means bigger volume. It can occupy bigger volume. Yeah, B, right? Right. So the B can occupy more water before you rise up, right? So the A occupy lesser water before you rise up. Something like that. Can you imagine that? So that's why the water, 1 kg of water, if it can to rise up 1 degree Celsius, it absorbs more heat to rise 1 degree Celsius. So that's why water has a bigger capacity, heat capacity. compared to the iron. Iron just absorb this, it can rise up. But water can absorb more heat before it rise up. That is a difference. Okay, understand what is specific capacity? All right. Okay, try to compare these two containers again. Okay. If I pour the water into these two containers, okay, to make it full, but no, which container is faster? A or B? A, right? Okay. So A is faster, rise faster. Okay, B, rise slower. Okay, so let's say you already make the container A and container B full already, yeah? So to pull out all the water from container A and B, which one is faster, A or B? A also, right? Right. Now, similar thing happen to the substance. If the substance has a smaller specific capacity, the temperature can rise faster. The temperature also can drop faster if the specific capacity is smaller. Now, for a bigger capacity, the temperature rise slower and drop slower. Something like that. Okay, is that clear? Anna? Okay, let's look at one questions. Okay, look at one question. Okay, look at question number 3. I have a try now. Send me your answer. Question number 3. What is the answer? Question number 3. Okay, let's see together the answer. Yes. Yeah, diagram 2 show you 3 block PQR the same mass. Same mass. The same amount of heat is applied. So the increase of temperature in the block R is higher than P, but less than Q. So which one has the lowest specific capacity? So answer is, if lowest means the temperature rise faster, right? Because you can fill up the container faster. So remember, when you increase temperature, higher mean it rise up faster. Okay, so think again your answer. Your answer is wrong. Yeah, the answer is Q. Q rise faster, highest. That means the capacity is very small, so you can fill up the container very fast because of small capacity. All right. And let's look at one past year question. Okay, look at question 14. SPM past year 2013. Question 14. Okay, try to answer this question. Yeah, okay, question, answer this question. Second a bit. Hey, let's see together. So there are two master block, same mass, heat simultaneously with identical heater. So after 15 minutes, the temperature of metal block is higher than temperature of metal block P. So that means Q rise faster, right? right? Faster mean the capacity small, so you can fill up faster, right? So faster, this one slower. So answer is A. It's okay? Can right. Okay, now let's move on to the calculation part. Calculation part. Okay, so let's say I have 1 kg of water. I have 1 kg of water. Its specific capacity is 4,200 joule per kg per degree Celsius. Okay. Okay, to rise up 2 kg of water for 2 degrees Celsius, how much of energy is needed? How much of heat energy is needed? Okay, find out now. To rise up 2 kg for 2 degrees Celsius. But it rises 2 degrees Celsius. See properly? Even though it's what 2 degrees Celsius. So 4,200 joule is for 1 kg and 1 degree Celsius. Do you see that? Per kg, that means for 1 kg and 1 degree Celsius also. But now you have 2 kg, 2 degrees Celsius. So what's the total heat energy is needed? So how? Now it's for 2 kg and 2 degrees Celsius. Okay, like that. To find the total heat energy, we say total heat energy. Total heat energy. So I use 4,200 joule per kg per degree Celsius multiply 2 kg and multiply 2 degrees Celsius. 2 degrees Celsius is the increase of the temperature. All right, so I cancel this, cancel this, cancel this, cancel this. So the answer is 4 multiplied by okay, yeah. Okay, now, okay, next question. Now you want to rise up. You want to rise up. You want to rise up temperature of 5 kg for 5 degrees Celsius. So what is the total heat needed? Oh, okay, 2 degrees Celsius. Okay, tell me what's the total amount of heat. Yes, okay, you get already. Okay, can I? So from here, actually, you can make a conclusion. Can make a conclusion. The total heat energy, let me represent it with a Q, equal to the mass multiplied by the C. C is the symbol of specific capacity. And then theta is a change in temperature. So Q equal to MC theta. Q MC theta. Okay, is that clear? So how to remember this? I always tell my student, QMC theta means you queue up in McDonald's to buy burger. QMC burger. So theta look like burger, right? Q up, Q up, Q up in McDonald's to buy burger. QMC burger. Okay. MC Burger. Okay. All right. Can I? Okay. Can I? Right. Okay. Now try question number 1. Send me your answer and number 2. Try it now. Question 1 and question 2. Okay. Try to 1 and 2. Send me your answer. Question 1 and 2. Okay, so what is the answer? Okay, now let's see together. Let's see together. Huh? All right. Question A is correct. Yeah, your answer for number 2 is wrong. Try again. Your answer is wrong. See again your answer. Your value wrong already. Your unique also wrong. Both also wrong. Unique and value also wrong. Here again, what's wrong in your answer? Okay, look here. You see now. If I have a pen, I tell you the price of the pen is 4 ringgit and 20 cents. 4 ringgit 20 cents is a price for a pen. So after that, I put 2 pens together. I ask you again, what is the price for 1 pen? How much is it? I put 2 similar pens together. If I put 5 similar pens together, I ask you, how much or what is the price for 1 pen? So for specific capacity, always refer to per kg. Even though I put 5 kg, 10 kg together, the specific capacity remain per kg. You get what I mean? So what's the answer for A and B? A and B, what's the answer? Okay, 4,200 joule per kg per degree Celsius mean this is for 1 kg. If I ask you 2 kg of water, what is its specific heat capacity? You also have to refer back to 1 kg. Still 4,200. The specific capacity for the same material is always the same. We don't see how many kg is it, because we always refer to 1 kg. Understand or not? Like you're buying the pen. I ask you how much per pen, even though I put all the pen together. All right. So get okay. Try question number 3. Number 3. Okay. I try first. Later I explain to you. Question 3. Now one more things. One more things. The theta is referred to change in temperature. Change in temperature means either the temperature increases or decreases. How much the temperature increase or decrease? That is called change in temperature. Change in temperature doesn't mean the temperature. You get what I mean? Now, for example, this term, you get physics marks. You get 60 marks, this term. This term, physics exam. Last term, you get 50%. Okay, if I ask you, what is your physics mark for this term? And you tell me 60%. If I ask you, what is the change of the physics marks this term you get compared to last term? The change. So how many marks? The change. 10 marks, right? So this theta is stand for change. It doesn't stand for temperature in specific condition. It doesn't refer to what is the temperature. It refers to change. So for the change in temperature in the MC theta, we always use the bigger temperature minus the smaller temperature. This is called change in temperature. Okay, is that clear? Even we don't see which one big, which one small. You use a bigger minus a smaller. Okay, is that clear? Right. Okay, you try question number 3 and number 4. Try now. Okay. Yeah. Okay. So normally we solve the question in this way. We label the quantity first. So this is M. The boiling point is 100 degrees Celsius. So it cool down from 100 to a temperature, final temperature, which is I don't know, right? Final temperature. I don't know what is this temperature, but I know it cool down, right? So in this process, this amount of heat has been released. So this amount of heat is 4,800 joule per kilojoule. Is 4,000. It's like this. So the M is 8 kg. The final temperature is hundreds. The change in temperature is 100 minus the final. Okay, or I put a T there. Yeah. So this is 4,800. Like this. Now you need to find the T. Okay, try now. How to find the T? Try to solve it. Remember the change in temperature, always use a bigger temperature minus a smaller one. Okay, how to find the T? What's the value of the T? So what's your answer? Yes. What's the value of T? Your T. Okay. You can do like this first. Yes. You can multiply the. You can solve this part first. So after that, this is multiply, right? you shift this to the other side. Okay, then you shift to get your tea. Now try first. All right. No, your working is wrong. This is like this. This is one. Let me see. Okay, 14.29 hundredths. To find t, you shift the t to the left. Negative become positive. Then you shift this to the right. Positive become negative. This is the way. Okay. Okay, yes, that's the answer. Okay, can I? All right, okay. Now let's look at question number 4. Number 4, your answer is 55. The answer is wrong. Question 4. Try again. I'll give you a few minutes to do it. Later I will explain. So can or not? You try first, later I explain. Okay, now let's look at question number 4. Let me take out the question first. Okay, question 4. The temperature for 10 kg substance rise 55 degrees Celsius. Calculate the temperature, same amount of heat. Okay, so that means there are two situations. The situation 1 is for 10 kg. 10 kg. The situation 2 is for 22 kg. So for the 10 kg, Q equal to MC theta. So M is 10 kg, C is C, theta is 55 because rise in temperature. So for the second Q, M is 22, also MC theta, but different M at different theta. 22, C, and then I don't know this, let me like that. But I know these two Q is the same, right? So I may equal, it become like this. Same, right? So MC 55 and then 22 C theta. Now both substance is the same substance. I cancel C, so I get these two. Okay, try now. How to get the theta? Okay, can I? So understand or not this one? Still don't understand? Can already? Can or cannot? Can already? Yeah? Can I? So answer is 25. You are correct. The answer is 25. Okay, try this past year question. You have a read. Later, I tell you how to do. You go through first. Now we have a try. Later I explain you how to do. This is a SPM common question. I have a try first. I'll give you 1 more minute to think. Later I explain. Give me a moment. Yeah. Okay, look at this question. This question, now. So 300 gram of liquid at temperature 90 degrees Celsius is added to a 700 gram of same type of liquid at a temperature 30. Now, so first of all, you have to understand that when they mix together, they will reach the same final temperature. When they mix together, must be the same, right? And last must be the same, So the final temperature will be the same. Same final temperature. So this is the first assumption. First one, because you reach thermal equilibrium condition. Same final temperature. Okay, secondly, you have to assume that all the heat released by the hotter object is fully absorbed by the cooler object. Now you have to assume like that. So this one release this amount of heat will be fully absorbed by this liquid. So release and absorb. So by then we can say in this way. Q release equal to Q absorb. Q release equal to Q absorb. Okay, so Q release equal to MC theta, Q absorb MC theta. You can say like that. Right? So Q release is 300 gram of water. So both is water, you can cancel the C. The initial temperature is 90. After you release, the final temperature must be smaller, right? So I use 90 minus T. So for the other side, initial mass is 700. 700. The final temperature sure is bigger than the initial 30 because it absorbs heat. It absorbs heat. Okay, so get. Now, can you get a T now? Try to get a T. Yeah. Now, okay, how to get a T? You try first. Later I tell you how to do. Yeah, so how to get a T? Try first. Can all right. Okay. So minus. All right. Okay, you try this one. Question number 10. Last one. Last already. You try question number 10. Last question. Yeah, last one.哪一个语是？今天只有2个学生，有一个学生只有我吧，还有一个学生，我可以比较放心一下。他学校运动会第二天了，那有运动会我，但是我没有。You don't know also. 好，交这个学，交我2次不懂。Okay, see how to do it. This one. This one I explain next time. I explain next time. You take out your module. Today you try this question. You mark down page number module. This one 4.2. This one you try all the structure question you have to try. You try this page number 14, 15. There's one more formula I teach you next week. Okay. I go through all these questions from page 14 to page 21. You go through. The answer is there. I sent you the answer already, right? Okay. So next week I will explain to you how to do the 考试的考卷. How to apply the specific capacity in different applications. Application next week, and then we move on to latent heat. Okay. Please adjust your mic. Because if no voice, we cannot conduct our lesson effectively and more interactive. Okay. You just check what is the problem in your mic. Okay. So I think that's all. So the today lesson can follow. Can Okay. So see you again next week. Bye bye.